Thanks to everyone remaining for coming. It's very nice of you, and let's try to have some fun. I'm gonna do less coding for you than I thought because it takes time, and you will be able to see more things. But let me encourage you to after this talk, try the kind of things that we are going to see. And the kind of things that we are going to see are the continuation of what Merced was explaining yesterday so nicely. About workflows. Remember, we wanted to make workflows like this one, and we were exploring solutions on the client side. The typical thing I have resources in my server. I want to combine them. This one was a workflow that you've seen today lots of times, and probably yesterday too. I never create a model just like this. I have to evaluate the model. So the thing that I always do is I start with my data set. I split the data set. I model it with the training. I evaluate with the test half. Right, so this is an example of the first workflow, one encounters, and we already saw that, well, you can do that in Python. This is more or less, you can simplify this code, but to get you an idea, this is not too bad. It's readable. But also, could we do better? It starts to be complicated at places when I have to wait for things to finish. And also, mind you, this is a nice code snippet, but it does no error control at all. What happens if I get an exception here, or here, or here, or here, or here? How do I recover from errors? Do I retry? And what about if these were 20 data sets and not only one? If I fail in the number 15, what do I do with the other 14? So things with such a simple workflow start to get complicated. And we tried, but we had a solution to this, even for workflows like this cross-validation workflow, because we thought, okay, and that was a simple one. What about a cross-validation? Remember, I take a data set, I split it in many times, I do many evaluations, and compute the average. Typical thing that you might want to do. We thought, okay, we have a solution for that because, this is a known workflow. I don't want to write this in Python over and over, all those other problems that I was mentioning. If I try to write this in Python, Node.js, COBOL, whatever is your language of choice on the client side, if I try to do that, it's going to be messy and complicated. Can I do better like with a more complicated workflow? And we discovered, or Merced was telling you that, yeah, indeed, you could. We can have a declarative tool, a declarative command line tool, where you, instead of saying how you want to create the cross-evaluation, what you say is what you want. I want you to create a cross-evaluation. And you only provide declaratively the what and not the how. And then inside, since this is a noun workflow, I can go and do always the same thing and even have some error handling strategies and so on and so forth. It's not that bad. It has problems, and I'll go to that in a second, because the message today is that you shouldn't be doing client-side workflows. But this is, in some ways, better for workflows like this one. But it's not enough. And moreover, workflows have this property of keep growing when you don't look at them sometimes. No, this is a workflow for predicting something with Watson. It's quite accurate, actually. But it was a joke. But it's not strange that you have this kind of workflows, and BigML is not going to solve that. The Python bindings, of course, you can write a program doing that. But can we do better? Like, what do we do with those kinds of workflows? Can we go on making things more complicated and recovering the simplicity that we had? Well, good news is that we think we can. This is all the problems that we have when we try to do things on the client side. I'm not going to repeat them, moreover, because Merced gave me a nice picture that she did. Thanks, Merced. With a very, very nice summary of what's going on here. So creating in the server, this is our servers, creating single resources is very simple. It's black box, it's abstract, it's declarative. I want to create a model, these are my parameters, and I want to create an optimal, please go on and create 2,000 models for me. I just wait and don't care about errors or anything. So single resources are very nice, but we have the workflow here. And we had get rid of complexity on the server, and suddenly it's reappearing on the client side. And that's our whole problem. Things are not abstract enough, things are not scalable enough, and what do I do? This is the situation. We have the REST API, and then we've been trying to abstract things, and we've been trying to automate things. And you see here the different layers we have been putting on top of each other. We started with the REST API. Then we had the bindings that make things much more abstract. You don't have to talk about HTTP verbs or anything like that. And then we tried with BigML declarative tools to make things even more abstract. This is substantially more abstract. And in this way, if you go through this axis, you have automation. Of course, the web UI is high in automation. It does all by itself. Well, you have, if you click enough times. And declarative tools are good at automation. But language bindings, automation is on you. And then, yeah, I have here, I want more abstraction and I want more automation. But I don't know what to do on top of this. If someone has ideas, she can send me a CV. Because what we did, instead of trying going here, was going back to the server. Because the server is the guy that was giving us all the simplicity, all the resilience, all the error handling, everything that we needed. Remember? All these REST resources were ideal for my problems. When it was about a single resource, a single ensemble, a single model, and so on. If the moment I have a resource there in the server and I can use it using an API, I'm happy. So why don't do the same when we are talking about workflows? It's the same idea. Everything is a resource in the platform. Why wouldn't a workflow not be a resource that is happening as any computation, and as any significant computation that can fail and that has to be parallelized? Why not putting it in the server? And that was the idea, quite simple. Yeah, already Paul told you that we like domain-specific languages, but the problem so we can put things running in the server, and why don't use Python running in the server? Well, first thing, because half of the world doesn't like Python with a passion, and the other half doesn't like Node.js. And we just choose a Lisp syntax because everybody hates it. So we are on the same ground to everyone. And moreover, because we really do want non-experts to write workflows. And know what? And that's my experience. The only people that complain about the syntax of Lisp are programmers. Normal people, non-programmers, believe me, they don't complain. They just have to learn something to write. And I could talk hours and hours and hours of why this is not so bad. I'll save you the sermon, but just contact me offline and we chat about this is not so bad when you see the syntax. So we are creating a DSL. I was very happy the other day discovering that even Facebook gets it right these days. If they were as clever with privacy, would be better. So yeah, they are thinking, they are using not only deep learning, they are using machine learning, these big companies, like since a long time ago. They were the first visionaries. And they are realizing that what you need is really a new language. You want to talk about machine learning. You know what? You don't want to program in Python. You don't want to program in Node.js. Actually, ideally, you don't want to program. What you want is to describe your problems and to talk the language of the domain. And the language of the domain is machine learning. It's not connecting to the database or connecting to HTTP or waiting or whatever. It's machine learning. So the way of doing that, of talking and narrowing the discourse, so to speak, to machine learning is having a ready-made language for that, a DSL. And that DSL is WSML. So WSML is actually two things. And let me go quickly with a demo. You've already, that was meant to impress you, but Paul already did it today, the Scriptify, so you already know how this works. I can go, but I'll do it anyway. You can just go. The moment I have these things that can run in the server, I can do the Scriptify thing, right? So I want to be able to run a workflow in the server. Every time I'm looking at a resource, I know exactly in the server the steps that produce that resource, every single one of them. And I have a language in the platform that can create workflows that are resources. And since this is a language that can create resources, it can also create other scripts, other workflows. Why not? It's a resource. Because I made workflows resources. So I have a language that can create resources, and I want to create a workflow, and the workflow is a resource, so I can use my language to create programs in that language. And that's what the Scriptify does. This is the remote diabetes. I downloaded it. I do the workflow very quickly. This workflow we are talking about all the time. I create the data set every time. Then I have to remember, oh, let's do the where's the split? I don't even remember. Here. Let's do the random split. Because now I want to have test and training, because I know I'm an expert now. After 2 days here, yeah, the message should already be that you should always evaluate things, right? So I have my 80%. Okay, now I create my model only with the 80%, not with the full training, with the full data set. And when I have the model, I have to evaluate with the remaining 20%. So once I again use my click here, my mouse, and where was it? What do I want? I want to evaluate, right? And the data set is selected for me. This is the model that I'm evaluating. And finally, this is my evaluation. I've created the model and the evaluation. I hope you will feeling like a bit bored already, looking at me doing this. Now imagine that every day I get a new data set and I have to do this over and over. That's not going to work. Moreover, I mean, if I can execute things in the platform, why wouldn't the platform do it for me? And that's what we have with the Scriptify. Scriptify will just, I'm doing this on an evaluation. You can try on any resource that you've created in the dashboard. What this is going to do is look at my resource, at the evaluation, discover that it was created from a data set and a model, that data set was a split, and it was the same split that was used with the model, and that the model was a tree, and then that original data set that was split was from an original data set that I downloaded from a remote source. And then when I finish, it has created for me one new resource, which is a script and execute. This is a script, because when I execute the script, I will have a new kind of resource, which is the execution. You have a script, you execute it, it produces outputs. Possibly you give it inputs, it produces outputs, and that result, that thing that was running, is yet another resource. It's an execution. We can try here. See, the system has discovered that the thing that I did was creating a remote source. So this is a script. Let me show you that it just appeared here in the list of scripts. This is the one that was created automatically for me. I didn't have to write any code, any Lisp, any nothing. It's there, should be executable, should run. So let's try it. It's a new resource. It's a list, like the list of data sets. I don't know. And let me check the URL of my data set, just to put the same URL and don't make a mistake, because, well, I only have to find it. Isn't it here? No, it's not here, sorry. I'll play a trick. Don't look. I was going to play a trick that is, no, I'm going to create, to pretend that I'm going to create a remote source. Sorry. I should have copy-pasted it. If I go to create a remote source, which I'm not going to do, if I had now a new URL and wanted to do the same using the web interface without automation, I will introduce here my new URL. And then all the clicks that you remember, and I haven't even configured anything. So what I'm doing is just copying the URL that I'm going to use, I know it's from a diabetes, so imagine that this is a file that's remote, that is my new file. I'll change the name, but I don't know if I copied correctly. Oh my goodness. I go to scripts. This is the one that I created. I click on it. I can execute it. I put here the URL, only the correct one, because that's an iris dataset. I'm going to download an iris dataset. This is the input. See, this is a black box. Okay, thank you. Thanks, Merce. Now it's okay. Thank you. Yes, you should be here doing this. Yeah, I didn't want to show the source yet, so that because they will get scared, and I don't want that. Okay, no. But listen to her usually, not to me. So I execute this, and this is, see, it's just like one click. It's just like creating a model. It's just like creating a data set, but it's going on creating resources and retracing all the steps that I follow to reach that evaluation. And it's already there, right, almost? Sorry about that. That's the evaluation. See, that's the evaluation. It created a source. There are 3 data sets, the full one and the 2 halves. There's a model. There's the evaluation of the model that I can also check here. You believe me, this is real and it's work. And it's work as I want. That's a workflow. Now I can call it from anywhere. And I haven't even coded anything. So that's the way I like things to go. And it's kind of magic. I like it. And you can try this with more complicated things, with more complicated workflows. And this is great for exploration. You are playing with the platform. You are trying many things. You end up with a model. You don't remember how you get there. But you like the model. It has the right parameterization. It's the right thing. And maybe you were making transformations. Maybe you were filtering with an anomaly detector. I don't know what. You have the right to reify that, to make that real in a resource that's a scriptify. And WithML gives you that. Again, Mercedes graphics. We've gone from here with these ideas to here. We've moved all this complexity, all this error handling to the server again. And then this girl is happy again. It's simple again, as it should be. And notice that there are lots of complexity here, not only the workflow itself, all the parallelization. The system, since my server is the one doing the job for you, I can parallelize things. I can analyze the code, because it's no longer a Python script running there without me having access. It's a workflow that I have on my side. So I can analyze that and discover what things I can run in parallel and optimize that for you. And I can recover from errors for you and retry. And you don't have to tell me. When you write a script, you just have to tell me what you want. And I'll take care of the rest. I cannot do that if what you are doing is writing client-side scripts. So yeah, you just saw that besides the fact that this is a DSL, which you are going to see shortly, the other thing that's happening here that's giving us this power is that we are using resources. These things, these scripts, these executions, also libraries. We never talk much about that, but I mean, the moment you are able to have scripts, to have executable code, you want to have libraries, right, to reuse your code. You don't want to write over and over and over the same functions. Of course, we have libraries. And this is a new resource, and it's already there in the server, and you can use it from there. And that's the other big idea here. Is I'm not only giving you the capacity of executing code. I'm giving you resources that you can manipulate as any other resource. And there are many ways of creating. You just saw the magic way. There's another magic way to creating scripts, which is the gallery. And it's another advantage. Sorry, but I never remember where it was. Where's my... I lost my browser. Sorry. Here. Where was it? I don't remember where you... OK. Also, that's another thing that having resources give us. Remember the gallery. We can put in the gallery models, and we can share them, and we can put in the gallery data sets. Guess what? We can put in the gallery, and we have scripts solving problems. So if I go to the gallery here, provided I click, you see I have here a gallery with lots of scripts that are solving problems for me. Some of them are complicated workflows, like feature selection. Someone was asking today about feature selection. That's one of the things that you can program in WixML. And that's one of the things that if we program, we can share. And you want to do first K, you just go to the gallery, you clone it, and you have a script. Let me clone this. This is kind of silly, but that's why I'm cloning it. No, it's because it's simple, and then I want you to see something simple. This is I think it's the first script that I ever wrote in BigML, in WixML, and it's a very serious script that is answering the question, should I use a model or an ensemble to model this data? And what it does, simply, it creates a model, it creates an ensemble, it evaluates both, compares evaluations, and tells me which one is best. Because if it happens that for some reason that the evaluation of the tree is already good enough, or is even better than the ensemble, I don't have to create an ensemble of 2 million trees for that, right? So this is silly, but this is a script that I once wrote and that you can now clone. This is a resource, just as we were cloning models or as we were cloning yesterday data sets, and here I have it. And here we've been tidy and we have a description. See also the fact that this is metadata. This is JSON, allows me to have metadata associated with the script. I can document the input parameters. I can document the outputs. I can document what the script does. And of course, I've been hiding this from you all the time. There's code, Lisp-like code there, but it's beautiful. But it's abstract. Let me go to the DSL part. So you can hide this for a moment. And can I hide it? Yes, I wanted to hide it again. Okay, no code. See, there's a lot of things that you can already do in WixML that you can already automate, like a pro, because this is controlling all the quirks, all the error controls, everything. So this is production quality code that you are using without writing a single line of code. You can use Scriptify, you can use the gallery, or you can send an email to support and ask us, and then we write a WixML. That's the thing that we do continuously. Like since we have WixML, before we had that, people would write and say, oh, I have this problem, how do I solve this? Oh, what are you using? Are you using Python or Node.js? Okay, you should install this. You should then, oh, you don't have the environment variables. Wait a second, just edit that. Here's the script. Oh, this is not the script that you wanted, blah, 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 and so on. You can imagine. We did that. We are software engineers, right? But since we have WixML, we just send a link to a WixML script. They clone it, they execute it, no installation, anything. And we've been able to solve their problems. And then if the script is nice, we put in the gallery. So this is nice and all, but you want to see the code. There are other ways I'll see you the script editor in a moment. This was the gallery. Just a comment that I like to make. I've already mentioned that programs are resources. WixML knows how to create resources. Therefore, WixML knows how to create programs. You remember, of course, this Scriptify button here that is creating a script. This is a WixML program that is scriptifying for you. So when we were able to do this, we were very happy. Because that's what I'm saying here, the power of introspection, right? And that makes all the system even more powerful, because then suddenly a workflow can orchestrate other workflows too. A workflow can use the results of other workflow, of an execution, to keep going. So you have a system that is fully integrated, that is fully composable. And you can put one script on top of the other and combine them easily. So besides being cool, it's very useful. Here, finally, I'm showing you some WSML code. Here is the workflow. This is all you need. This is all the error control that you need, the parallelization that you need. All you have to do the evaluation. So this is simpler than, you might not like the parentheses, you might not like the syntax, but it's objectively, just forget for a moment if you don't, what it is much more abstract, it's much more compact. It's only talking, it's a domain-specific language, so it's only talking about the operations that you are interested. You want to create a dataset split with some ratio, that's the seed. You want to create a model using this create dataset split is giving me two values, a train ID and a test ID. These are the two halves of the dataset. I want to create a model, so I call create model with the train ID. And then when I have the model and the test ID, I just call create evaluation. And if I just want to give it a name or parameterize that or whatever, I can add parameters, of course, to fine-tune the creation. But notice that I don't have to worry if this fails or if this fails. This is running in the server. We will take care of that and retry for you. I also don't have to worry. There's a little detail here, but remember that we had to do in Python this API OK, because this is a REST minus thing that, I mean, you have to wait in Python when you are on the client side. Before I can create this model, I have to wait to create this data set. I have to wait until this data set finishes. And before I create the evaluation, I have to wait until those two guys are done, if I'm on the client side. But since here, and then I have to make decisions. When do I wait? And what is more efficient? If you stop for a moment to think of that, it's not that immediate. And especially when you want to run this in parallel, it's tricky. But here I don't. Here I'm running in the server. I'm analyzing this code when you send it to us. Well, not me personally, but the system. And it knows when it has to wait. When we see this call here, we know, OK, we better wait until this data set is done. Same thing here. And when we see this thing here, OK, there are here two resources being created. We can do that in parallel. Let's do it. And yeah, you don't have to wait for that because probably it will be finished here already. Or maybe you can, or you must. Let's find the best combination that makes this efficient. And if this fails here in the middle, I'll know where to go back. And I'll retry for you, and I'll make this transparent. So you see, this thing about having a nice DSL pays off. And makes things, I mean, I don't know if you think simpler, but it's really at least shorter. And again, remember, if you're a software engineer, our previous Python scripts are not the Python scripts that you would write. You have to control errors. And we were not doing that. Here, this is production code. Moreover, you are not in a silo like, oh, now I have to do everything in WSML and none of my client-side workflows is going to work and I cannot interact. No, not at all. They are fully interoperable because executions, scripts, are resources. So in the same way, that's again Python, and I'm again on my client side. And this is the script that I just created. It has an ID. And in the same way that I can create a model from a data set very simply, I can just create an execution from my side and wait until it finishes. So there's nothing precluding me to use these things also on the client side. Maybe it's convenient, maybe it's not. And moreover, while the previous Python script was not failure-safe, this one mostly is. There's only one point of failure that I can take care of, but all the possible errors are already taken care of. Just like when I created a model or when I was creating an optimal, in your Python code, when you are creating a model, you don't worry about how many servers we use, how we parallelize things, or how many errors are happening. Here is the same story for the workflows. So we have also simplified the client side considerably. let's play a bit with this example, shall we? Because I have time. Any questions? Since I have time so far? No? Okay. Okay. You are not asleep at least, I think. If I find my browser, with all these languages, you are all used to that. What you usually have is a REPL, right? An interactive prompt where you can play with the language and evaluate expressions, especially when it's a list-based and an expression-based language. It's very easy to evaluate things and to experiment. And we have a web-based REPL. If I go, for instance, to the list of scripts, I have this button here, the little hat, which if I click correctly, I don't know how to click, will bring me to a REPL. A REPL is something where, what's this? I don't want to update any password. A REPL is something that lets me write expressions. You by now know a lot of Lisp, so you won't be scared. I can do, by the way, Paul mentioned that in WSML you have the full power of a programming language. There's nothing that you cannot do, and usually we strive to be able to do things as succinctly as possible. So you can do all kind of local computations, and of course you can also do things like the one I was doing with my script. So let's try. Imagine that I'm experimenting. I don't know if I can copy this. Maybe I can. If not, I write it, but which is more realistic. But no, I cannot. I don't know. Wait. I don't know how to use computers. What's this? I guess I have to do the Control-C thing. No? Okay, I'll write it. Okay. Let's say I'm experimenting. I want to create a dataset split because I want to know how this function works. So I go to the documentation maybe, or I start typing here. I know that there's something that is creating datasets. Maybe I start writing, and then I ask for completion. Okay, I have here the dataset split. Let me check how many. I can go down here before, and this is a function. I can evaluate a function, and simply will tell me how many arguments it has. Oh, it takes a dataset, a rate, and a seed. Oh, now I need a dataset ID. Let's go here and quickly copy, although I don't know how to copy, but let's copy a dataset ID. I'll go to the dashboard and take that. Take my dataset ID. By the way, all this, of course, is interoperable, and everything that I'm doing in WSML appears in the web, and the other way around. I can use things interchangeably. This is one of my diabetes dataset. It's a small one, but I can use it nonetheless. This is the ID. I'm just trying to copy it. Let's see if I succeed this time. And then I want to do a dataset split. This is my dataset ID. This is the rate, and this is a seed. Every time you do a split, you do something random. If you want it to be reproducible, you want to provide a seed. That's typical. I can try. Thank you, Mercen. Yeah, she was pointing out that the ID was wrong. By the way, there's a direct translation between the API and WSML. All the things in the API are JSON parameters. And the way you write a JSON parameter, a JSON mapping in WSML is just as in JSON, only shorter. This thing that I just wrote will be a JSON. How you write that in JSON, you need a colon there, right? And if you have more than one key, you need a comma afterwards. In WSML, and that's because it's a Lisp, you can do things like that. You don't need to worry about commas and colons and whatever. You can directly there's no ambiguity because of the parentheses. Not everything was going to be bad. So this is just what I'm trying. Let's create a dataset split and see what happens. I'm doing that interactively. And you see it returns a list of two datasets. That was my train, the first half and the second half. And I can keep on playing. Okay, let's do something. How would I create? Next thing I want to do is create a model. So I can just go here again, maybe start writing. And maybe there's a little detail here. This thing about waiting for you, remember that I told you when you write a workflow and it's executing in the server, you don't have to wait for things because we know how to wait. Now this program, this WithML that you're seeing here is running in the browser. It's not running in the server. So we have different implementations. And WithML, there's a virtual machine, and we can execute it in many places. When we execute it in the server, we know how to wait, we parameterize, blah, blah, blah. When we're executing here in the browser, this is a JavaScript implementation, we are not that clever, and we don't wait for you. So there's this little difference. But when you're experimenting, you are not trying, what you won't do is create at scale resources in the REPL. This is just for discovery. So here you have to remember to wait for things. Since I've been talking a lot, the dataset is almost for sure. The datasets are almost for sure finished. So I can go and create a model. Let me do it here directly. I can go and create a model, and let me use this dataset to create the model. Okay. So I'm creating a model, and by the way, if I go to the website, you'll see that in datasets there was two halves of the dataset. This is the 20%, 31 instances. This is the 80%. See that I just created them, and if I go to models, I will see. I don't know how to click here. My model. Just created the diabetes model. So everything that I'm doing, of course, can be traced back then. And then I create the model, and then now that I have the model, I can check this nice create evaluation function, which is going to take a model and a data set. And it doesn't matter the order, actually, because we know which thing is which. So I don't have to worry about whether the model comes first or comes second. With ML, we are going to. This was the second data set, remember that? And it's the one that I'm going to create the evaluation. Provided I copy it. Click here. OK. And then I've created the evaluation. See, here it is. If I were quick enough, I would see it, but I'm not quick enough. I would see it going on, because I wasn't waiting for it, right? It already finished. Okay, so here you see me playing with the REPL and executing things. And all of this, well, I was telling you, all of this is happening now in the browser, but I don't have to install anything. And I can explore the language, I can play with it, I can do things. And then when I'm happy, I will go to the server and I will create a real script that runs in the server. And I could do that, right? Let's do it. So I'm happy with, so I was experimenting with this, I only have to find it, with these primitives, and I'm happy, things seems to work. Now I can go and create my workflow, just to show you that it's not, well, what I would do is just find a text editor, writing my code, and upload it to the platform, and create, with my code and some metadata, create a new resource that is the new script. I wouldn't go here to the web and edit it with the script editor there, but that's me. Because if you use Sublime, and if you use Emacs, if you use Emacs, send me your CV, or you use Sublime, send me also your CV. We have modes for that, like highlighting modes, and you can write WithML in an IDE environment. But what I'm showing you here is how I would create a script, a simple script like that, for running it in the server just from scratch. I just go to the list of scripts, and I won't show you this, but I could also put the code in GitHub and import it from here. That's very useful if you are sharing code with your colleagues and you want version control and so on and so forth. You put your BigML scripts with the metadata in GitHub, and you can directly install the workflows for your user from GitHub. But what I'm going to do here is just use the source code editor, and I couldn't copy this before, right? And I'm not going to be able to copy it. Let me try again. No, it goes away. Copy it. It said copy it. And then why not? It's not copying, but this is not BigML's fault. Let me tell you. I will write here the code, right? I mean, I will write here the code. Like, okay, let's create a script that just creates a model given an input data set. And then I say, okay, my script, we have a result, which is my model, that will be created using create model from a given data set. Okay? And maybe, just for the fun of it, when I create the data set, I'm giving it a name. Okay? That's how I write. That's how I would do it in the API. So in BigML, it's just the same. Okay? Now I write this, and now, notice, there's a variable here, name. That's not defined anywhere. It doesn't have a value. This one will have the value returned by this call, but this one doesn't have a value. So it must be an input of the script. Of course, I can have input parameters. If I validate that, if I validate, what did I do wrong? Sorry. Told you, parentheses are terrible. Sorry. Here, now. I validate the code is fine, and it's telling me, oh, there are two things that I don't know what they are. They are this variable that's called dataset ID and this variable that's called name. Please tell me what that is, because when I'm going to execute this code, I need to know these values. Those are the inputs of the script. So I'm going to tell the system that this name is going to be a string, and this name, this dataset is going to be a dataset ID. Where is it? It's a dataset, and this name is going to be a string. And the output, I could not give any information, but since we are at it, I'll say that the output is a model. The output is whatever it is. And I can give it a name, just to not use the default, simple, and I create my script. And then, when the system shows me the script, and then I've created a resource, a remote resource. And notice that I've given it metadata, I've given it information, so it knows that dataset ID is a dataset. So I can, when I open it here, it's going to search for my datasets, and only those datasets. So that's very convenient, and this is the name I want to give this model, and I just can execute the script, right? And it will create for me a model. This is the result. Remember, I called the result. It's finished. I can go and see my model. And I can also go and, besides seeing my scripts, here, this is the script, and I can also look at my executions. So I have a full trail of all my executions. This is the latest one. I executed simple, and it has these outputs. So that's also very good for testability. I have all the things that I run. I have all its outputs. I have all its inputs. And as everything in BigML, it's immutable. And then, just to finish, just so that if I find, just to try to convince you about the goodness of a DSL, just to give you a glimpse of how easy it is to make things parallel when you have a DSL. This is the code for creating one evaluation, using one data set, doing one split, and creating an evaluation. Now imagine I need to do this 1,000 times. And I want to do it using as efficiently as possible my resources, the number of parallel tasks that I have, with error control, and so on and so forth. In Python, just think for a bit, if you had to take that one that created one data set, one split, one evaluation, and had to make that work reliably for 1,000, it wouldn't be trivial. You have to decide. Remember that there were 4 places where I had to wait and decide where to wait? How do I wait that? How do I wait there? And then how do I control errors? What I was saying before, what happens if the failure happens on dataset number 25? Do I do the same as if it happens in 99 or not? But so your script, if you try on the client side, is going to grow like 3 times its size, typically. In BigML, to say, oh, look at this. I want to do this in parallel with error control any number of times. You go from here, and you go from here to here. So from here to here. So the complexity of the code is more or less the same. And it should be because what you are saying is, I want to do these operations many times. So I wrote the same operations, only many times with a for. So I don't want to enter in the details, but it's not difficult to understand on anything, especially if you're a programmer. And the nice thing about this is that these are not sequential operations. These are things that will run in parallel, that will be retried, and so on and so forth. So this is production quality code already. So I can go from one side, from one simple problem to a complex one. This is it, and it will work for me. By the way, you again have the same benefits on the client side because I started with this simple Python script for creating an execution for one data set. Now that I have 1,000, the script is just this one. And again, nothing else is needed. I go from just one data set, is even simpler. I go just from one data set to the data sets that I want. And this will work, and I don't have to worry about parallel things or resources or anything. And with that, I'm taking questions. I don't have stickers. Otherwise, I will give you a sticker for a question. Yes. Retries. Internally, whenever you are creating a resource in BigML, unless there's an error in the inputs or in the parameterization, you are asking for something that's impossible, and then there's an error. If there's an error like that, the resource, in the same way that a model can fail, and you get an error, and you have a way of handling that error because it's part of the JSON document of the protocol, is the same for an execution. If we cannot continue, you will have the same kind of error. But by default, if what's happening is that it's a recoverable error, we internally retry. This is already happening when you are creating an optimal. When you say that optimal, and there's this nice list of things there finished for you, maybe there were 100 servers running and 2 or 3 errors already because those things happen, right? So we already have the infrastructure to do that. And so we just scale up that. So that's ideally, if your script makes sense, if what you are wanting to do is doable, you should be fine. What can happen if you are very unlucky and have 3 errors and we have to retry again is that it takes a bit longer because we are retrained. But from the outside, what you will see is an execution that is progressing just like any other resource and that finally gives you the answer. Yeah. Another cool use by the way, of BigML is Optimal. Optimal, that complicated algorithm with Bayesian optimization and all that Paul was explaining, is in fact implemented as a BigML script, which was another thing that we wanted to have to be sure that the language was powerful enough. So all these operations that you see in BigML, or this error control that I'm telling you, is actually running a real WSML script. And I remember that back in the day when we started using WSML, we didn't have yet OptiML in the platform, but we wrote a WSML script for doing that optimization. And then we could send it to the people. And so it's also a way of extending the platform without us having to write backend code specifically for that. More questions? I'm already past my time, no? Yeah, we give time for another question if they, or any criticism. What do you like, or no? There's nothing not to like, but just in case. Between what, sorry? No, because this is running in the server. For you is if you have a browser, or you have this is all running there. You can even use it from Windows. No, it's sorry, couldn't resist. Sorry for you Windows users. Kidding aside, it's one of the powerful things that it runs. Since it's not running locally, it's transparent for you, and that was one of the problems we had when you came to BigML, to the support channel. Oh, write for me a script that does that, and we did that in Python. Yeah, it depended a lot on the local environment. Jan was describing the guy from Rabobank was describing a similar thing this morning when he said, "Oh, I don't want to have Python programmers because of traceability, because the code is there and I don't have any control of the environment." So yeah, the idea is that you recover that control because it's all there. And it's immutable, and you can trace back what you did. All the executions are there, and all the parameters that you use, and the time they took, everything is there.